Your ICP sample introduction system has a great impact on the performance of your instrument and productivity of your laboratory. To meet these requirements, Glass Expansion is pleased to release a series of dedicated, high-performance sample introduction systems to maximize performance and minimize downtime. In our high-performance sample introduction system webinar series, you will learn how to make the right choice to get the best results and reduce operating costs while minimizing downtime. We're excited to kick off our high-performance sample introduction series with a highlight of our new HF-resistant high-performance sample introduction system for the Thermo Fisher Scientific Pro Radial and Duo ICP-OES. Firstly, please allow me to briefly introduce our company. Glass Expansion is a world leader in the research, design, and manufacturing of ICP sample introduction components. With over 4 decades of experience, Glass Expansion has earned a reputation for quality, precision engineering, and reliability. Glass Expansion's product portfolio includes torches, RF coils, nebulizers, spray chambers, peristaltic pump tubing, and ICP-MS interface cones. Glass Expansion has pioneered important innovations in the ICP sample introduction, including the industry standard cyclonic spray chamber, our trademark micromist and sea spray nebulizers, the ISOMist XR temperature controlled spray chamber, and the patented D-Torch demountable torch with ceramic outer tube, in addition to essential quality control tools such as the TrueFlow sample monitor, LUO nebulizer cleaning tool, and Guardian inline sample filter. And many of these designs are supplied as standard equipment on several ICPs because of their reproducibility, longer lifetime, and dependability. Reproducibility, quality, and dependability provide ICP laboratories with a significant long-term cost savings. Glass Expansion's products are designed to last longer and provide optimum performance. And when a replacement is needed, there's no wasted time re-optimizing due to Glass Expansion's unique and proprietary manufacturing methods, which enable the production of components with the highest mechanical accuracy and precision. Our commitment to research and product development, which includes owning ICP-OES and ICP-MS instruments from several manufacturers, enables us to provide innovative design solutions and conduct real-world testing that leads to the best possible performance, consistency, and reliability for your laboratory. And with our warranty policy, you have our guarantee. The standard sample introduction system of your ICP determines many factors, including detection limits, precision, different matrix tolerances, and costs. ICP performance can often be improved by careful choice of a torch, spray chamber, and nebulizer components, taking into account the types of samples that will be analyzed. Today we will highlight Glass Expansion's new HF-resistant high-performance sample introduction system for the Thermo Fisher Scientific Pro Radial and Duo ICP-OES. Each month we will highlight a new high-performance sample introduction system, so be sure to subscribe to Glass Expansion's mailing list for regular updates. Let's get started by taking a detailed look at each component and highlight the unique design features of each Glass Expansion product. Choosing an inert nebulizer is very important. Key categories to review when choosing an inert nebulizer are chemical resistance to hydrofluoric acid, purity, tolerance to particulates, and overall performance, including sensitivity and precision. This way, the best nebulizer is chosen for the application and sample matrix. The Duramis concentric nebulizer is made from PEEK. It is the most economical inert nebulizer for high precision analysis. It is highly sensitive with excellent short-term precision and the highest tolerance to dissolved solids of any concentric nebulizer. It is a great all-arounder and ideal for high throughput labs that require a good balance between durability and sensitivity. The serviceability is also high, as the capillary insert can be replaced if needed. In 2016, Glass Expansion introduced the direct connection DC gas line, providing an upgrade to our U-Series nebulizer product line with an inert, metal-free, ICP-specific gas line. The reliable ratchet click and seal fitting to the nebulizer gas arm ensures a leak-free gas connection by clicking or ratcheting when a proper seal has been achieved and preventing over-tightening. At the other end of the DC gas line is an ICP-specific quick connect to the argon gas supply. This improved gas connection helps to maintain optimum back pressure for consistent day-to-day nebulizer performance. All DC nebulizer models also include our trademark UniFit sample connector, which easily slides over the sample arm of the nebulizer, creating an excellent seal and zero dead volume sample connection. Here's an example of our DC Duramus nebulizer installed on the Thermo Fisher Scientific Pro Duo. The DC gas line has replaced the original rigid gas line with a more reliable and flexible gas line. In summary, the DC nebulizer benefits include an inert, metal-free argon connector, ratchet fitting to ensure leak-free gas connection, and the direct plug-in gas line connection to the instrument. Most ICP laboratories use an internal standard to compensate for interferences and enhance both short-term and long-term reproducibility. Glass Expansion's Trident and new Trident CT provide an easy and accurate solution for dosing all of your samples with internal standard without extra effort or risk of error or contamination. The Trident is installed in between the nebulizer and peristaltic pump, and each Trident kit is completely modular so that worn components can easily be replaced. With each Trident kit is a compact, efficient mixing chamber which ensures complete mixing of the sample and reagent. We have a kit for aqueous and one that is HF resistant, which is pictured throughout our webinar today with our HF resistant high performance sample introduction system. The use of inert metal-free CT ratchet fittings with our new Trident CT mixing chamber provides simple to use leak-free connections for the internal standard and sample every time. Now that we covered the nebulizer selection and benefits of the use of an internal standard in the Trident kit, let's discuss the difference between Glass Expansion's trademark twister and Tracy cyclonic spray chamber models. The twister cyclonic spray chamber features a central transfer tube, often referred to as baffled or a double pass cyclonic. This feature provides a smaller particle size and narrower distribution compared to a single pass cyclonic like the Tracy, while the Tracy provides a greater transport efficiency leading to greater sensitivity. However, greater sensitivity is not always the best solution. Smaller droplet sizes reduce matrix effects and can improve short-term precision, making the twister the most suitable choice for a higher matrix sample. The twister and Tracy are available in glass, quartz, and PTFE or PFA for inert sample introduction systems. With our high-performance sample introduction system, the performance goal was sensitivity, which is why the PTFE Tracy cyclonic spray chamber was chosen for our HF-resistant high-performance sample introduction system to suit the Thermo Fisher Scientific Pro Radial and Duo ICP-OES. For ICP sample digestions that require hydrofluoric acid and/or if the final sample matrix contains trace amounts of hydrofluoric acid, a glass or quartz ICP sample introduction system is unsuitable. For these types of ICP analyses, an inert sample introduction system consisting of a spray chamber and nebulizer made from various plastic materials is used. A major breakthrough in the performance of inert spray chambers came with Glass Expansion's introduction of our proprietary steady flow surface treatment. The steady flow treatment improves the wettability of the surface, ensuring efficient drainage and delivering sensitivity and precision comparable to those achieved with a glass cyclonic spray chamber. A common problem with inert spray chambers is that the polymer materials do not wet completely and large droplets collect on the inside walls. The formation and collection of droplets degrades ICP performance, leading to erratic drainage, poor precision, and poor signal stability. The steady flow treated PTFE Tracy spray chamber is nearly equivalent to a glass spray chamber. In addition to the steady flow treatment, the PTFE Tracy cyclonic spray chamber also features Glass Expansion's Helix CT interface. The Helix CT locking screw and seal uses a constant torque ratchet mechanism to provide a zero dead volume, gas-tight seal between the nebulizer and spray chamber for consistent performance. In addition to a reliable installation of your nebulizer, the analytical benefits of the Helix CT interface include consistent performance, as ICP sensitivity is affected by both nebulizer depth within the spray chamber and the torque applied to the nebulizer seal. The combination of the torque control and positive stop, which fixes the penetration depth, allows the ICP analyst to achieve the same nebulizer performance every day. Superior washout. The Helix CT interface is also the only zero dead volume spray chamber interface available, providing superior washout, especially for elements that are prone to carryover. Inert and O-ring free. The Helix CT is a chemically inert seal immune to strong acids and organic solvents, eliminating all the drawbacks of an O-ring seal. This also improves user safety. These design innovations have provided the Tracy spray chamber sensitivity gains, reduced washout times, and reduced matrix effects not possible with other spray chambers. And this brings us to the final piece of our high-performance sample introduction system, the ICP torch. The ICP-OES torch is typically the most often replaced and a higher annual consumable cost for laboratories with complex matrices like hydrofluoric acid. Many ICP-OES manufacturers have moved away from a single-piece torch to a demountable torch for this reason. Glass Expansion's patented D-torch is a high-performance and economical alternative to the standard EMT torch. The D-torch, often referred to as a super torch by our customers, incorporates a ceramic intermediate tube for greater robustness and provides the analyst with an outer tube that can be replaced when it fails rather than replacing the entire torch body. The D-torch also features an interchangeable injector, allowing the analyst to install a specific injector, material, and diameter for each application, whether it be for aqueous, organics, high total dissolved solids, or hydrofluoric acid. Also note that all EMT compatible injectors are also compatible with our Pro Radial and Duo D-torch. Each Glass Expansion D-torch design is a direct replacement for the standard torch. Just like the EMT design, the D-torch model is designed with a base that provides the same self-aligning turnkey installation. Glass Expansion pioneered the design of ceramic torches more than 20 years ago. Using a ceramic outer tube on your ICP torch provides a hotter, more robust plasma, which reduces matrix effects and improves detection limits. Compared to a quartz outer tube, the ceramic outer tube also has a much longer lifetime, greatly reducing maintenance and downtime due to torch failure. Today, a fully ceramic D-torch is available for a wide range of ICP models, including Agilent, PerkinElmer, Spectro, and Thermo Fisher Scientific. Before we discuss the results of our comparison, let's briefly review the components of Glass Expansion's HF-resistant high-performance sample introduction system, which consists of the Duramus Nebulizer, Trident mixing tee, coupled with the PTFE-Tracy cyclonic spray chamber and fully ceramic D-torch, which was paired with a 2.0 mm ID alumina injector, all of which are shown here, in addition to a picture of them all installed on the Thermo Fisher Scientific Pro Duo ICP-OES. To evaluate performance of Glass Expansion's HF-resistant high-performance sample introduction system to the standard HF-resistant sample introduction system, we compared the relative sensitivity and relative signal-to-root background ratio. All experiments were conducted under identical conditions using a Thermo Fisher Pro Duo ICP-OES. First, we looked at the sensitivity of the standard HF-resistant sample introduction system relative to Glass Expansion's HF-resistant high-performance sample introduction system. The data collected here shows the relative sensitivity is improved by an average of 35% using Glass Expansion's high-performance sample introduction system combination of the Duramus Nebulizer, PTFE-Tracy cyclonic spray chamber, and fully ceramic D-torch. The best indicator of analytical detectability for ICP-OES using a solid-state detector is the signal-to-root background ratio. Similar to what was observed when comparing sensitivity, the combination of the Duramus Nebulizer, PTFE-Tracy cyclonic spray chamber, and fully ceramic D-torch provide a 40% average improvement in the signal-to-root background ratio over the standard HF-resistant sample introduction system. Before we conclude our webinar, we wanted to provide some helpful product care and maintenance tips to help maximize the lifetime and performance of your Glass Expansion high-performance sample introduction system. First, let's cover nebulizer maintenance practices to avoid. Do not insert anything through the orifice of the nebulizer, including wires, probes, or even hairs. This is most likely to damage the nebulizer beyond repair. Never touch the nebulizer tip. Any deposit of body oils can have a detrimental effect on the performance of the nebulizer. Do not use any concentration of hydrofluoric acid to clean a glass or a quartz nebulizer. Even dilute hydrofluoric acid can alter the orifice of the internal capillary and deteriorate the performance of the nebulizer. Do not place a glass nebulizer in an ultrasonic bath, as it may dislodge the internal capillary. And do not use hot liquid to flush the sample capillary of an inert nebulizer like the Duramist. The temperature can potentially deform the capillary and vastly affect the nebulizer performance. The LUO nebulizer cleaning tool is designed to efficiently deliver a cleaning solution through the nebulizer capillary to dislodge particle buildup and thoroughly clean the nebulizer. We suggest using the LEO regularly to maintain nebulizer performance and prolong nebulizer life. Glass Expansion has two LEO designs. One LEO for our glass concentric nebulizers, which include the sea spray, conical, micromist, and slurry, and a separate LEO is used for our inert concentric nebulizers such as the Duramist and Opal Mist. As mentioned previously, your Glass Expansion PTFE-Tracy spray chamber is treated with our proprietary steady flow treatment process. In order to maintain optimum performance and prolong the lifetime of the treatment, do not use hydrogen peroxide and avoid making any physical contact with the interior surface of your PTFE-Tracy cyclonic spray chamber. Should performance degrade, washout issues, or poor RSD occur, it's time to clean the spray chamber. First, try nebulizing a 2.5% solution of Fluca RBS 25 for 15 minutes, followed by the same rinse with DI water. If this does not recover the performance, remove all fittings from the spray chamber and soak overnight in a container of 25% Fluca RBS 25. Thoroughly rinse with DI water the next morning. Eventually, the steady flow treatment may degrade to the point where it does not recover after soaking in Fluca. At this point, the spray chamber needs to be returned to glass expansion where the surface can be retreated for a nominal cost. Like all products, every glass expansion inert spray chamber has consumable parts. The Helix CT, seal, and drain line should be checked regularly and replaced when necessary. But the inert spray chambers also have an O-ring at the base cap that needs to be checked and replaced. If your spray chamber is leaking, do not over-tighten. This will damage the spray chamber. It's more likely that the O-ring just needs to be replaced. In summary, for those ICP laboratories that require the utmost performance in an inert sample introduction kit, Glass Expansion's high-performance sample introduction system combination of the Duramist, PTFE Tracy cyclonic spray chamber, and fully ceramic D-torch is the optimal choice. The results presented in this webinar indicate that sensitivity and signal-to-root background ratio are both improved by an average of 35 and 40% respectively with the Glass Expansion HF-resistant high-performance sample introduction system. In addition, Glass Expansion's products provide unique trademark design features such as the DC gas line, Helix CT interface, and steady flow surface treatment, which are far superior to the standard HF-resistant sample introduction system. Following proper maintenance guides and tools will guarantee optimum performance, longer lifetime, and significant long-term cost savings. Thank you all for your time today. If you have any questions or are interested in a quote, you can contact one of our 3 offices directly. We also have a global distribution network that can be found on the Glass Expansion website. And remember to subscribe to our mailing list for regular updates on our high-performance sample introduction series. Or you can visit www.geicp.com/HP-SIS. Thank you again.